Okay, so I'm happy to be here. As we just discussed, I don't get many opportunities to talk to people in the public. I usually end up talking to other administrative types, so this is great. And I get to talk to you about something that keeps me sane. It's something I've been working on since 1998 over time, and I hope you'll find it as interesting as I find it. My job is technically I'm the chief of the Protected Species Division. Okay, so that's monk seals, that's cetaceans, whales, and that's sea turtles. But I also, before I got into that, started working on these corals. So that's the kind of work you're seeing here. So first of all, I'd just like to quickly go over what deep corals are. They're azooxanthellae. So those of you guys who are used to hearing about corals, you're aware of zooxanthellae. That's the plant material that's inside of the coral tissues that are down there that gives it color. It's part of the photosynthesis process that generates the food. But deep corals don't have that. Okay, they're sitting down. We have them as shallow as 50 meters and as deep as more than 2,000 meters. And the shallow ones are the black corals. That's the ones you guys hear about. And they're suspension feeders. So they basically sit up in the water column, and as the water goes by, all of the little organic stuff that's in that water is what they filter out. That's where they get their food. They're very slow growing. They tend to be long-lived, and they're independent colonies, so they don't build reefs. Okay, so there's no big reef down there. Here we have an individual colony here, different places. All right, so why did I get into this initially? Because I was in fisheries. In fisheries, we have a precious coral fishery here in Hawaii. And this is a fishery that basically harvests these corals. And the big ones that they harvest are the pink, gold, and blacks. And the way to estimate the age, it's just like a tree. You cut it down, you look at the rings. You count the rings just like a tree, and that'll be how you come up with the age. So they assume they were annualized. So each ring is each year. That's how they work on it. Basically, they've gotten pretty good at the pinks and they've gotten pretty good at the blacks, but a gold is one we'll be talking about a bit more. And they really didn't have a validation for that. All the fishing has happened in the main islands, and almost all of it has happened at the Makapu'u bed out here. Almost all of it, okay? And as you can see, in 1966 to 69, they used this right here, which was a dredge. You used to put a pipe on the bottom, a bunch of net, you drag along the bottom and break it up. And they bring it up, but they stopped doing that in 72. And they required everything to be done by submersible, individual collections, selective harvest. And then in 1999 to 2001, they were restarting the fishery, but then they found it wasn't viable. So there really hasn't been a fishery since 2001. So we call it dormant. So this is what they collect it for. You guys probably have seen it. This is precious coral jewelry. This comes from all over the world. The stuff that we have here in the United States that's harvested here, basically it's harvested under a fishery management plan, where there's a quota, a set amount that can be taken. It's looked at relative to growth rates. So basically that's what the reason that this fishery exists. So I'm going to go through the corals in a very general sense, because the truth is a lot of us debate whether we really know the species or not. We don't, so we talk them by genera. So I'm going to divide them into things like crustose corals. This is kind of like your shallow corals, the stony corals. These are the hard ones, okay? Look at them carefully, because there's going to be a pop quiz later. See if you guys are ready to be able to identify them. If you look at this right here, this is a coryllium, that's a coryllium, and that's a coryllium. That's what most of the pink coral is made out of. A lot of the stuff worldwide is made out of pink coral that occurs in the Mediterranean. And in the Mediterranean, they can scoop it out of down and collect it. And they overfish it because everybody can get it. Here, you can't get it unless you go down and eat by a submarine. So the fishing is very, very controlled. So it hasn't been actually the same kind of overfishing that's occurred in other places. There's also dendrophilids, which are here. These are all stony corals. If you were to go and try and push the branch a little bit, it would snap. It would break off. Okay? If we move to another type, which are sea fans. And there are different types of sea fans. Some of these are black corals, which they occur shallow, they occur deep. Some of these are these paramerecid fans. Some up here are the, like this is the deep water black right here, a Leopathes or a Bathypathes sea fan. These things, if you were to bump into them underwater, they'd be pliable, right? So that's a key thing, a morphological difference. There's other types here, Calagorgia, right? Oh, sorry. Calagorgia, and then the one I wanted to point out here is these things right here. These are the gold corals, and I'm going to be talking a lot about that today, these gold corals. One other sea fan I want to highlight that we're going to talk a lot about is bamboo coral, and there are a lot of different types of bamboo coral. You can see the bamboo structure right here, the little nodes sticking through. This is the tissue, decorticated. All the tissue is off, and you can see the bamboo skeleton. Bamboo is one of the things they actually use to make jewelry as well. So it gets a minor harvest. But there are many different types of bamboo. And, you know, it's, if you look at some of them are whip corals, and these are types of bamboo as well. And so you'll have these long whips, and they'll be 6 feet long. All of these things are pliable sea fans. You push them, they're going to be able to flex in any direction. It'll be apparent why I'm dividing them into these categories as we go further into this talk. So here's our pop quiz. Now, if you were to go out to the mock pool bed, you drop down in a submarine, you'd hit the bottom, and then all of this dust would be in the water column. But then you might see this. This is a nice cross-section of all the different types of corals there. So if anybody would like to take a guess, would you like to guess what coral that is? Anybody want to make a guess? It's a sea fan. That's right. Absolutely, it's a sea fan. This is a bamboo coral. Is this a sea fan? Yeah, I heard somebody say yes. That's right, it's a sea fan. What about that? What's that right there? Is that a sea? Is that a crustose coral, or is that a? That's a crustose coral. Exactly. Very good. Right here. Oh, you're going for tender feelings. Somebody thinks they're a pro. That's pretty good. No, this one right here. Maybe that right down might be able to come on there. But that's a paramecic a fan there. So the point is you've got a huge mix. And I want you to think about going along the sub and seeing this. You have to be able to say, all right, there's one there, and keep track of it. Look at this guy right here in the middle. Which one's this? Well, that's not dendrophilia, but it looks a little like this one, right? So that's a bamboo. But then what's the bottom look like? Gold, right. Now, here's the key. They're the same thing. We're going to talk more about this later. The same colony, large bamboo and gold, the same thing. So I'll make it back to that. So anyway, I also want to talk about deep coral ecosystems. When I was assigned to deal with precious corals, one of the things we looked at is what animals live with them, because that's primary. You can remove that. They want to know what the impact of that is. We looked at the fish associations, the vertebrate associations. We looked at monk seals, and we looked at the environment that occurs. Now, we also put together a national report on deep sea corals. But you're probably wondering, monk seals. Why did we just say monk seals with something that occurs so deep? Well, monk seals, basically, at the time when I was doing this, I was also basically brought in to work on the foraging of deep water monk seals. And I was using CritterCam. We basically looked at cameras and we attached them to the backs of seals. And this allowed us as a means to basically look at what habitat the seals were going to, what they were eating, what was important to them. And this was in conjunction with National Geographic. And it was a lot of fun. Let me tell you, I had a lot of fun doing this. But as we put out like 40 different cameras, one or two seals were doing some interesting diving. They were going really deep. And then they were coming up from the bottom. And when you go really deep, we couldn't see anything because there's no light down there. I couldn't see a thing. I could hear the seals scraping the bottom. But then they were coming up with fish in their mouth from, down around 300 meters, real deep. And so that was pretty exciting stuff, okay? First of all, to see them go out, to go down, get the fish, come back up, and then I don't know what's going on. We embarked upon a study, and Tyler Abernathy was the lead in this study. And what he did is he took the seals and he put satellite tags on them and sent them out there for like 3 months, 6 months. French Free Shoals is the place I spent all my time working. That's where he was working. This is an atoll in the northwestern Hawaiian Islands. So they put the tags on the seals, let them go for months at a time. And these black dots are where the seal spent its time. Now the thing here is it's nice and shallow here. It's real deep out here, and it's real deep over there, and it's real deep in all these places. If you notice, the seal has 2 places it likes to spend its time. But it's got to swim across a lot of deep water, but it's spending all of its time here. So it makes you wonder what's out there. What is the seal finding so interesting? Now at this point, I'm working on corals over here. I'm working on seals over there. We got this. This is really interesting. I'm thinking, what could this be? And when I was looking at it, I was thinking, I was working in the submarine on the corals. Let me back up one thing here. Working on the submarine on the corals, and this is, go through it. Yeah, this is what it looks like in the sub when you're down there. You can go on the bottom for a long time, and it looks like this. And you're saying, okay, what is the seal finding so interesting down there? And there was a time that before we had ROVs to support these subs in scouting the area, we would go down and sometimes we'd just see sand. But with the sub, we now have the capability to do more than we ever did before, but we still have to look at a lot of this type of boring habitat. And I was thinking, what could possibly be there that'd be of interest? I guess one thing I would like to say is that I want to talk a little bit about the sub. This is it's a tight surface we have here. It's located right over there at the Makapu'u point. You can see, I know Janie Culp works here now apparently, and you can see some of the artwork done by Terry Kirby up on the wall. But it's a tight little situation. You get in there, and this is 4 or 5 pictures glued together. And if you guys were in the sub, you'd be right here. This would be where you'd sit. And you'd look right through that window right there. And then if you're me, you would bang your head on that right there. And so I tried to wear a wool cap, to keep myself from getting hurt. But let me tell you, it's exciting, it's fun, and you never get tired of it. It's really cool stuff. Down there, when we got down to the bottom, this is what we found where the seals were diving. We found walls covered with these big gold corals, really large gold corals, which is pretty cool. First of all, think about gold coral. When you're in the sub and you're cruising along, your lights are out there, and if it's way off in the distance, because it's gold and it's yellow, it fluoresces. You really see it. And then the next thing you know, it explodes in front of you. And it can be big. It can be 6 feet tall, 7 feet tall. Okay, I got little samples here, but they can be really, really big. And so Terry Kirby, after seeing that, he was really excited. Terry Kirby is the pilot. And you see over here, he's been doing artwork. Well, he did some artwork on that one, and he basically drew this because he wanted to commemorate the fact that we were out there down showing an interest in what monk seals were showing an interest, which just happened to be deep corals. Now, I just kind of laid it out. We got monk seals showing interest in deep corals. We have the fishery showing interest in deep corals. And we have some questions about deep corals. There was another group that was really interested in deep corals. That was the people who wanted to harvest them. And they were really interested that monk seals knew where the deep corals were. We didn't really know why they were going there, but they actually joked with me saying, they'll save us a lot of time looking across the bottom. So there was a real interest in us getting a handle on deep corals, knowing what it was. And since the seals were finding gold coral, we said, okay, well, we know black coral. We've done the surveys. We've got the age structure over time. We have the data. We know how fast they grow. We've done it with red coral, but we didn't have anything for gold, none. And so what you do at that point, you use a proxy. You say, okay, it's a protein coral that grows, and we have black coral, which is a protein coral. And we're going to assume they're pretty close to the same, and we're going to assume it's annual growth. That's a normal thing to do, and that's what we were doing. The thing about it is that there was information occurring. In 1995, Ellen Druffel, a scientist, was doing radiometric work. That's where they do the carbon dating. And she found out that in the Atlantic, gold coral was 1,800 years old, full size. And in 1998 to 2003, the NERP and OE supported coral surveys across the archipelago. We found, there's gold coral across the whole archipelago. And during that time, Brendan Rourke, in 2006, did his own radiometric studies of all the different corals, and he found majority is thousands of years old. And so we were thinking, whoa, can we harvest this and it's thousands of years old? And this is Brendan's study right here. It really pushed us into, okay, now we're uncertain about the growth of gold coral. We don't know how old it is. And so the ring counts, which is the way we would normally do it, said that it would grow 6.6 centimeters per year. So this coral right here, which is 50 centimeters tall, is about 40 years old. That's okay. We harvest things that are 40 years old. That's pretty straightforward. But the radiometric stuff would say that this thing is 450 years old. So, the goal of this work is to test to what degree the ring counts, using Markov measurement would dictate it. So do you use the ring counts? Or do you basically use the radiometric data? And the ring counts basically, it's just saying, okay, there's the diameter of a cross section and the number of growth range. And the ring count gives you a nice correlation, but we didn't know. So in 2000, so that was in 1998 to 2007, and 98 and on. We did surveys up the chain. I want to show you the different places we went. Starting right down here at Keahole, the Big Island's the youngest. That's 0.4 million years ago. You go to 4 million years ago at Makapu'u. You go to Westpac, which is 7 million years, and it gets older and older. And then we went to Cross, and the interesting thing about Cross is this is a Cretaceous feature. It's not part of the Hawaiian Archipelago. It's 100 million years old. So you have the youngest and the oldest place right next to each other in the same place. That's where we did our surveys. And let me take a look. While we were doing the surveys, let's see if we can do this. Let's see. Well, it's not going to go up. But while we were doing the surveys, we had a seal come down and actually visit us. And then the pilot was again excited and basically did another piece of artwork. So Terry Kirby put this together to commemorate this monk seal. So now the monk seal's coming down and showing interest in what we're interested in, which was the opposite of what we had before. So what do we do? To get to this growth rate thing, what we did was a really high-tech experiment. And it really came to me on the way to getting on the stuff to leaving. We were going out to do surveys, and I'm going, how can we get to this? And then it just occurred to me that the only way to really do this is go to a coral, find it, put a mark next to it, measure it, go away for a long, long time, come back and see if it's grown. So you need high-tech stuff. I was on the way to the ship. I didn't have anything, so I went into my mother-in-law's garden and stole her flower pots. That's what those are there. Sweep them up. She still doesn't know where they went. Sometimes she says, where are the flower pots? So anyway, so then you put high paint on, leave it. And so I left it. So the earliest one I left was like in 1998. And then, you do this over time. Basically, you do a lot of different things, big colonies, small colonies, lots of different colonies. And then if you look right here, this is the 1998 colony, and you can see the shape of it. And I want to point out this little brown part, that's another zoanthid. Gold coral's a zoanthid. That's another little zoanthid golden. You see that little white little piece there? And then this is in 2007. It's the same coral. And it basically hasn't changed at all. And after I saw this, I realized that if I were able to get out of the submarine at this depth and just stand there, in 10 years, I would look like this. I wouldn't change at all. And that was the cool thing about this, is that these things were really slow growing. So here's what you see if we look at the data. Basically, this right here is the line projected. See this line right here going straight up? 6 centimeters a year. That's the growth. You would expect a colony to get taller along those lines. These are the years on the bottom. There's 9 years difference. And then these little dots right here, oh, I'm sorry, let me show you this first. This dotted line right here, that's the radiometric growth. That's what you would expect over time. And these little dots are all my measurements. And there's a lot of error in it because I can't go up to the coral and actually do this. You have to use a laser scale to do that. And so as a result, they're all clustered right around this line. So I can't prove anything, but I can disprove 6 centimeters a year. And that's what I did. So we got rid of 6 centimeters a year as the growth rate. We started using the radiometric growth rate. So we produced another paper. That's what we do. They basically put that in the thing. The management council looked at it, they basically evaluated and said, okay, we're going to put that in the moratorium. The precious coral fishery said, cool, no problem, we understand if that's the case, so they were good about it. So, we moved on. But here's the thing, after that project was over, there's this thing that was really bothering me. And it was this photo right here. Here's the key thing. This white point right in the middle, that is bamboo coral, okay? This is gold coral. Gold coral grows around bamboo coral. Okay, so it's not, when we say we're measuring the heights of coral, it really bothered me to what degree we were actually measuring it. You're measuring something that jumps on something else. But here's the weirdest thing about it. The weirdest thing about it was a given that bamboo coral grows to be 75 to 130 years old. And we know gold coral grows really, really slow to grow hundreds of thousands of years. So if you're going to grow on something that grows and dies faster than you can even grow, how can you exist? And that was the thing that was driving me nuts, because clearly there's a rapid phase of growth in gold coral's life history that we didn't know about. And it exploits the height of the host, I thought. You jump on a big colony, and you slime all over it. It's right out of Alien. It was so cool. It's right up my alley. And then basically, you would have this thing which would basically take advantage of it. It'd be big. So think about it. If I'm a big bamboo coral and something gets on me and slimes it, Tyler's picture right here is perfect. He just made this cartoon. This is perfect. You're just sitting here, and then you get a little bit of gold touching you, and then it starts to slime you over, and then suddenly that gold can take advantage of the fact of how tall you are, and it feeds better, and does better. I thought, that's probably what's happening, and so I wanted to continue to study. This is what we started to find when we started looking around. This is exactly what we were thinking about. Here's a little bamboo. It has some open, dead skeleton. And in this piece right here, you can even see the little nodes underneath the gold tissue. So this one right here is in a phase of transition. Something's happening there. And if you look really close on the bamboo, you can see right there are little tiny spots of gold. And the beautiful thing is gold coral is fluorescent underwater. In fact, you turn the sublights off, you take the manipulator, and you wipe it across the corals, it will glow. And it's cool. And it was one of the reasons we were thinking monk seals ended up going there, because maybe monk seals cruising down deep and an eel was cruising along the gold coral, and it would flash, and that would just be a signal to the eels to go eat. It's sort of like a toaster coming up with a toaster oven, and basically you go, oh, it's time to go get something. So they were just spending more time around those areas. So, Midas phase, gold, changing something, made sense, we call it a Midas phase. The closest thing I can show you on the terrestrial world is the strangler phase. Okay, you guys are probably familiar with it. This tree basically jumps on other trees, overgrows it, and then here it's even overgrowing this temple. And we actually see some of that in some of the examples here that I've got. Afterwards, when you come up, you can actually see it sliding down and cementing things underneath. So I started referring to this transition as the Midas phase. So until you're fully covered with gold coral tissue, you're in transition. So I'm going to say you're a Midas phase colony. So
is it considered parasitic then?
It is definitely parasitic. You might even say it's predatory, because a good parasite tries to keep its host alive as long as possible, right? But in this situation, the idea is eventually to subsume the host. So if we go through and do the surveys across the entire archipelago, write down, if you remember, here's the Keahole, the youngest. Here's Cross, the oldest. These are the sites in between 100 million years old. And here are the number of colonies we saw per 100 meters squared of survey from the sub. Now remember, we were looking out the sub, we were trying to find it. Here's what I point out, sea fans. Remember the category of sea fans? Look at the sea fans tend to be higher in the places where we have younger island features. As we get to the older island features, we have more gold coral. It's a slow growing coral. It's going to take a long time to basically colonize and start it. This colonization is succession. If you guys remember any of your plant stuff at basic school, when you go there, it's the first ones, the pioneers that come in, settle. Then you have other plants feed in, so it might be seeds, like grass, and then, or if you go like the marsh over on Kailua, you have the reeds out there, so it's a marsh. Well, when does it become a swamp? It becomes a swamp when there's 51% of the area is covered by trees. More things fill in, it's succession over time. So gold coral is our greatest succession indicator at this point. And if you look at if you look at bamboo right there, these are the bamboo ones. You can see that what happens is that the numbers of bamboo would go up, the numbers of gold go up, but the size is what's interesting. Down here with the red line is the height of the corals. And if you look at this, this is the only place where bamboo is higher than anywhere else, and that's at the youngest site. So it's a situation where you got enough hosts, they basically get the coral there, and then basically coral truncates the size structure. It basically jumps on the big ones and starts keeping the size structure down after that. Okay, Midas colonies. There are not a lot of Midas colonies. I went out there on all those surveys, and this is all I saw. And look at the scale there. You're talking about 10 individuals here, and 1 there, and 2 or 3. So I didn't see many. I mean, the surveys that I did, I just didn't see many at all. And I'd point out that most of them, 5% of, okay, I saw 459 goals total is what I saw. 5% of them were Midas colonies. Most of them were bamboo. And there were some Midas colonies on other types of corals, other types of sea fans. I never saw a Midas colony on a crustose coral. No. So. All right, so ready, guys? Now we're going to focus. You guys have seen this photo a couple of times. Believe it or not, I've shown it a couple of times. Can you see the gold coral in it? Because the truth is, I wasn't looking for gold coral. I was on my way to driving away with the sub, and then I saw it twinkle at me. Because just as the light got low, there's a certain light level where a fluorescence is clear, and when you can see it, then it actually jumps out. This one right there, you saw it?
Yeah.
You got it? Right on. Well, that's it. That's it. That's 9 polyps. That's 9 polyps. This tree is this tall, and there's 9 polyps right here in the center. And so what do? We put down a pot, right? It's a highly scientific flower pot. We put it down in 2007, and it's not like I know that I'm never going to be back there. I just go around begging people to give me money for a sub dive so that I can go back and look at my flower pot. So we go back and look at the flower pot in 2012. And there's the pot on the side. And there it is. We're in a slightly different place because whenever you land with the sub, it depends on whichever way the current is blowing that day. It's kind of like being in Zeppelin. You don't really have a choice of your angle. But right here is the top of the goal, and right there's the bottom of the goal. And you can see it's really covered a lot of that branch. So let's keep going. We got Keahole, another one right here, pot 11. Small little bamboo. Look at where the gold is here. It is not on one branch, it's right at the intersection of all the branches. Okay, go back 2012, it's almost entirely covered. Now this is a small colony, didn't have to cover it quite so much. Is this still a Midas colony? Absolutely. There's a little bit of bamboo left. As soon as that's gone, sorry guys, it's gold. You get to be a Midas for a very short time, 5, 7 years maybe when you're this size. Okay, let's go again. This is pot 12, 2007. If you look at that, you can see that this is the submarine right here. This is a big colony, and you can see that the gold is actually going up to points here and here, and that's the edge of the branch here. If we go to the next year, you'll notice that a lot of the branches are gone. Some of the bamboo is actually broken away. It's not even there anymore, but we still have growth in some areas, so it continues to grow. I picked one that I saw that wasn't bamboo, and so this one right here is a little. This is the California. I got to look at the book again, but right there you can see the middle stem. That's the gold coral tissue on it. Come back. It has some growth. It's moved over to the second stem, but maybe it doesn't grow as fast on this coral as it does on bamboo. I only have 4 observations. That's it. Guess what? I put this in when I wanted to get it published, and the reviewers looked at it. They said, no one's ever seen this stuff. Nobody gets to go back and do repeat visions. We're going to publish this. And so it moved through really quickly. So I'm really grateful they let us go back and take a look at it. So this is all of them. This is what it looks like when you see the tissue up close. So 2.2 centimeters per year is on average what I guess, based on what I saw. It's definitely displacing the host tissue. The other ones we saw, they were sitting on the dead bamboo coral. This is sitting on the live tissue. So this stuff can actually push out other corals. So if it lands on you, it's going to basically push your flesh out. Anyway, so let's move on to this part. As we were driving around, I noticed that there are a lot of dead coral skeletons on the bottom. And this is typical of what you see. They'll grow to a certain size, then the drag will exceed the holdfast, and they'll kick over and they'll fall down. So it looks like, an old tree lying on the bottom. I started thinking that this was an opportunity. If I picked up the dead ones and sectioned them, I could see how much the skeleton, the host, is inside there, because my belief was that they were taking advantage of the height. So I found 9 toppled skeletons, and I went through and I sectioned them, and I have some of the sections up here, and you can take a look at it. What I found was surprising to me. There were 8 with carbonate cores. That didn't surprise me. What surprised me was the mean height of the host was like 9 centimeters. Now, we saw some of those really big bamboos. They were tall. 9 centimeters, that's the average height. So I didn't really know what to think of that. But if you look at the inside, what you can see is there is in the core, there's branching, 3, 4 branches, and then it's gone. So clearly, this was a big colony, and they colonized it, but then pieces would break away. And so that's a big change. I guess the other thing that struck me is that, the other thing before I say that was a letdown for me. If you guys heard me talking about it earlier, big coral, colonize that one, and you basically do this huge thing taking advantage of the height. I was really excited. That was my pet theory. Well, I kind of disproved that wasn't the case. And I was actually frustrated because after I spent all weekend cutting them up, I went to DC for a meeting. I got in early and was wandering around and was unhappy that I wasn't going to be able to say that was true because I was able to show that it's a Midas trade. But yeah, what happened was I tell this story because it is true. It's a true story. I didn't know what to do, so I kicked off went into a theater and decided what taking a movie, and I was going to take in Spider-Man. Walked up to the theater, it was 3 in the afternoon, and I got in the theater, and there's a room full of seats, and it was empty except for one guy right in the middle there. Where I looked up at him and I said, "That's where I was going to sit." And the guy looked at me and he says, "Well, if I'd been sitting there, would you have wanted to sit there?" And I said, "Sure." And then as I sat down, I realized, well, maybe that's what it's all about. It's where you're going to settle, not necessarily how big you are. And I realized that basically that's what gold is doing. Gold is taking advantage of the fact that the bamboo coral has already selected a site that has excellent feeding opportunities. And all you need to do is get that site. If you get on that site, even if you knock him over and you grow, you're assured of success. I started to feel pretty good. In fact, I actually wanted to go down and get in that seat with that guy and break off his limbs. But, in the end, I came back and that's how I've been dealing with it. But this right here is an interesting piece. I think it's this one right here. And it's toppled, it fell over, and it has some live tissue on it. And so I started to ask myself, well, how long has that live tissue been on? It seems like if you fall over, the tissue should go away. And then I really started to wonder, well, maybe they live a long time. Does it take a long time to die? And so slow death is what we looked at. And what happened was back in 1998, one of the colonies that we marked was standing, and we left, and then we came back in 2007, and it was, no, not 2007, 2001 or something like that, and it flipped over. And we found it, and we said, okay, and it was 100% alive. And then we came back in 2007, and then it was partially dead. Then we went back in 2012, and it looked like this, still partially dead. So I'm trying to see if I can go back up there and see if it's going to be alive in the future. So it takes a long time to die. It's not like you're just because you fall down. That doesn't mean that you're done contributing. You basically are still have polyps and you're still functioning. And then you start looking around and you start seeing, not only that, you have some growing up, like some we see in our plants. So this guy right here, toppled, he's 1 in 12. So based on the height of those stems sticking up, that's 180 to 318 years ago when it toppled. So that's how long ago it toppled. Now, look how tall it is. That might be 2,000 years ago that it settled. You know, and some of these guys, you could be talking about the time of the pyramids when, you know, this kind of stuff is going on. So there's another one that's toppled right there. And what's interesting here is you can see that it's got a coral growing up on the side there, and one of its branches is still successful, but the rest are not. You can see that other things colonize it. So there's other zoanthids right there growing on it, and you know, it provides a settlement source. It even has a little bamboo growing on it. So the bamboo is now colonizing the gold techniques. The truth is that bamboo will probably go to whatever size, die, fall over, and this gold coral will still be here, rotting very, very slowly. So made me really wonder at this point, okay, so how often does you actually get a settlement by gold coral? It's got to be, the life issue's got to be very strange. You know, it's got to be a situation where the planula, that's the baby coral, comes in and it settles. It grows on top of a host quickly. It spreads over. That's the fast part. Then it grows the protein skeleton, the thing you make jewelry out of, very, very slowly. And then at that point, you know, it topples and then it dies very, very slowly. And then it rots even slower after all the tissues are done. So there must be very localized recruitment. It must be very, very infrequent. And I started thinking about the French Frigate Shoal site when we were doing the surveys there. This is a sub sonar image right here, this clip. So that's basically broadcast out and tells me where the rock fields are, and that's where you get the corals growing. If you, right here's the middle, this is where the seals were diving to. And you go out this way, you go out that way, go out that way, go out that way. These little red brackets say, yep, that's where all the gold coral is. And I felt pretty good about it. And then I went back in 2007, and the sub drifted over here and dropped down in here, where we hadn't surveyed before. And we found a whole bunch of bamboo with just 1 or 2 mites on it. And I'm like, I've never seen all these bamboo before. I've been here 4 times. What's the story? So my thinking was this little rock, which was off by itself, was far enough away that it was more infrequent delivery of larvae to that site. But to do that, you need a time machine. To be able to go back in time or forward in time to see that. And I don't have a time machine. And my solution to everything has always been a submarine. And we have a submarine. In World War I, the S-19 basically was taken up and sunk off of Oahu here. It's because basically World War I was over, and then Germany and the U.S. had this deal that, okay, we're going to get rid of our World War I submarines. I guess Germany kept theirs and we dumped ours. And they sent it down, and it happened to set down right in a nice sand field out there. It happened to be in the exact same depth as to where the corals were, you know, as far as the depth range and all that. So that happened 75 years ago. So this is an opportunity because there's a couple things you can do. You can't go back in time, but you can put a new piece of habitat down and see what colonizes it over time. And we do that already. We don't mean to. On the Big Island, you actually have lava fields and flows going down, you know, and that's new habitat. But the thing is, you really can't control where it is or how it tumbles or what it looks like. This is just a very discrete thing put down for us to see what grows on it. So we got a sub dive to go look at it, just so you know. This is in the spectrum of where things are. The S-19 is only 75 years. Everything else we looked at, Keahole, that's 250,000 years ago based on the reef that it was growing on. That's the next youngest. So S-19, 75 years. Are we expecting to see any big gold coral trees growing on it? Probably not, because they're too slow, right? Anyway, when you cruise up to take a look at this thing, this is the first thing that I saw on the back end, and some people pointed out that looking at it, it looks like you've discovered the Nautilus sitting on the bottom of the ocean. It's really, really cool looking. And you know, you can say it, but when you're down there in the sub looking at it, you're getting goosebumps. It's really, really very neat. So looking at the sub there, this is what we saw. We saw bamboo growing on that stack there, bamboo growing over there, bamboo down here. These are full-size bamboo. We saw 11 bamboo colonies on this submarine, okay? Mean height, you know, we figure they're basically 55 years old. So that means that, you know, we know it's been down 75 years. Took, you know, it took 20 odd years to get to where it would start to colonize, and now they're colonizing. Not a single gold, but more importantly, not a single Midas colony. Midas had not found this in 75 years. Now, more interesting is if you look at the closest hard bottom feature, because this is sitting in a sand field, it's nearby, there are golds everywhere. So within 1,000 meters of this, up current of this, there are basically all these golds, and we're talking about old golds too, growing, you know. So this one's been full size, it's been there for 1,000 years or more. And basically they're producing larvae, but the chances of the larvae actually encountering the host sitting on the S-19 are very, very low in 75 years. It's going to take longer for that to happen. We even have a Midas colony right there sitting amongst these golds, and this one's colonized a little black hole. So there's no reason we shouldn't be seeing larvae coming out of this. It tells you it's very sparse, very, very sparse. So let's push the button there. So just kind of thinking about this, in 1938, you know, we put down the S-19. So that's 75 years, right? There it is sitting on the bottom. Okay. Over time, 2015, we got a bunch of corals, a bunch of bamboo corals growing on this thing. Made me start to think, time machine, where are we going to go in the future? What if the S-19 wasn't the S-19? What if the future was take those corals and put them on the Nautilus? Okay, the Nautilus has been sitting on the bottom of the ocean for 150 years. At the time, Jules Verne basically, you know, lost it. So it would be sitting here. So let's assume we're at the 75-year point for the Nautilus. And then you would look at what it would take if I were to come along with my submarine with a piece of gold coral and just leave it on the S-19 and swim away. What would happen at that point? You know, basically, maybe in another 75 years, we'd actually start to see gold coral starting to take over this whole vessel and start exploding. And that could test it. You could actually see if you could put one little coral next to, you know, the bamboo coral, you could actually see if it would colonize. Now, we're not going to do that because we've got a great experiment going to do that. But that's one of the things that's kind of cool about thinking about, you know, using these kind of things. This submarine, the S-19, is actually serving us a really good purpose right now. The Navy, you know, well, just put it down there, just said we're done with it, but they know that we're actually looking at it and they're saying, yeah, that's a good use of an old submarine. So, anyway, so I just point out that more Midas colonies are found in bamboo coral. In a matter of decades, the gold coral subsumes the surface area of the bamboo coral at a very rapid pace. This new gold coral is a host coral with a thin exterior protein skeleton, so it's very slow after that. Once you get slimed, it's very slow to get the protein skeleton there. And then the recruitment is localized, and this is key here. The recruitment is localized and infrequent. Otherwise, the speed of the Midas phase would saturate all the hosts before they could replenish. Think about it. What if we didn't have few larvae going out? What if we had lots of larvae going out? Let's say there were as much as plankton out there. Then there's no way the host could survive in those depth ranges. They just get burned out because basically the Midas would just coat them so quickly that they wouldn't be allowed to replenish. So it's very important that it be a slow process. Otherwise, gold coral will basically be host limited. It'll lose its host. The future, there's always other things we want to do. We look at the environment. We look at current flow. We can look at things like that. And one of the reasons we're interested in it is, just like tree rings, you could take these and you put it in a machine and you look at the elemental analysis. across those tree rings, and you can look at element change. Now remember, this time right here is hundreds of years. And this is the water chemistry over hundreds of years. So you can see, it's capturing things that are not even, outside of our lifetimes, okay? And you can actually use it as a record of water chemistry. So that's something that people are trying to figure out, how to actually look back in time and see how chemistry has changed. And since everybody's talking about climate change is something we've had in the past, and we're just trying to figure out what our role is and how we fit into that case. And so this is one way to use skeletons to maybe get to that. And then finally, I'll say that the reason this talk is happening now is that I'm leaving on Thursday to get on the Oceanus Explorer. That's the new NOAA vessel that basically has an ROV, real-time thing, goes down. I'm going back to my places that I just put there. So it's been 3 years, so I'm going to go and see if my dead coral is dead yet. I'm going to find out if the corals that have slimed, whether that one coral is now, I can call it a gold, or is it still a Midas colony? So the reason I bring this up to you guys is that if you're interested, you can go down that dive with me. You can get on that HCP site, okay? You can basically look at the timeline. You can basically sit there and you can look at your computer. If you have a smart TV at home, you can basically run your YouTube through it, and you can basically watch it in the comfort of your home, petting your dog, and you can probably hear me on the phone making inane comments. And look at the gold corals. And that's assuming we're able to get down there, we're able to find things. There's lots of things that can go wrong with doing these types of dives. You don't know what's going to happen. It's always an adventure. But the reason they put this together was to get live streaming so that the public can actually see this. And Oceanus Explorer usually does pure exploration, going out looking at new places and finding new things. But this is the Deep Coral, the National Deep Coral Program has given some money so that I can go and chase down some of these specific little details, get my instruments back. My instruments are sitting down there, so we're trying to get them back. And it's just not only this cruise. If you look at the website, there's a cruise going up to the northwestern Hawaiian Islands. There's a cruise going to Johnson Atoll, and it's all focused on deep corals. But this weekend will be these sets of the sites that we're talking about. And that's really all I've got to say. So if you have any questions, you're welcome to ask.
Yeah. You originally thought that the gold coral was colonizing based on the type of the bamboo coral, but that wasn't the case.
Yep.
But it's still colonizing bamboo coral more than any other coral.
That's right.
There's something in particular about the coral life cycle that makes it more prone to gold coral.
That's very good. And maybe it's a redeeming aspect of it, because one thing about bamboo corals is they grow taller. So it may not be that you need to be tall, but it's just that you're straining more water than anybody else. And so you're going to get more Midas colonies on you as a result, because if you're big, you're straining more water, so you're more likely to encounter a planet, right? A bigger net, you catch more planet than a smaller net. And so that once that large bamboo gets a gold on it, it can get all broke up and fall in pieces or whatever. And then as long as the gold has that spot, it's going to do fine. So that may be the reason. It may have something to do with size, but I thought it was because you would use the size, you'd stand on the shoulders of your host, and get even bigger. But if you actually look at the golds, they're all asymmetrical. Bamboo is very symmetrical, bilateral symmetry. It has arms out to both sides. But if you look at gold, it has arms going every direction. That's because it's broken off the arms, and now it's just doing whatever it wants to relative to the current flow.
Anybody feeding on the live coral?
Feeding on live coral? Yeah, there are some things we know very little about it. There are urchins, and then we don't know about those zoanthids that we talk about. There are other types that are really beautiful purple zoanthids. There are brown zoanthids, a bunch of different types, and we don't know if they're competing and pushing each other out. But the urchins, there are some brittle stars that we don't know if they're feeding on it, but they're using the coral as a place to basically get food from, so they may be getting some slime or something like that.
What does fisheries have to do with the coral?
I know, it doesn't make any sense at all. Well, it's fisheries is the reason is the first fishery management plan that ever was made here in the state of Hawaii was the precious coral fishery, and that was specifically to harvest the corals for the jewelry trade. So that was the first fishery management plan. It's not the important one right now, but because it's pretty much become dormant. But that's why fisheries was involved with it. And then the point was that the monk seals was the other side of it. We were in charge of protected species. And protected species were actually going down and showing interest in those kind of habitats. So we had two things that directed us to this.
So fishery in this word means that they were going down there to
Harvest
take
them.
the harvest.
That's
the
right.
coral.
And the only harvesting that's ever been done is right off of Monteputo right here and a little bit off of the Kona coast. So that's all the managed harvest that's happened. So it's very select locations.
And did you decide what the seal's interest in the gold corals was?
Well, we never really knew about it. In some respects, it may just be that they're swimming out in the ocean and that there are some fish around the gold corals. And then, anybody go fishing and go out by the fads, the fishing buoys? So what do? You get on your boat, you go offshore, and the first thing you do is you pass by the fishing buoy, right? And then you go out and you search around, and then you head home. What do? You go back by the fishing buoy. Just because something might get attracted in it. And then if it brushes up against the coral and then it glows, you don't even have to look very hard. You just basically say, they got these big, beautiful eyes, they got low light capability, and then if a coral fluoresces underwater, bioluminescent, no problem. Somebody else?
How big do the bamboo corals get?
And that bamboos will get about this big. That's about as big as they get. They don't get much taller than that.
So the gold outgrowing.
Yeah, they go way beyond. And so when you look at some of these things, like for example right here, you can see the host. Right inside, that's the bamboo. And then you don't see the host up here. You don't see it there, you don't see it there. You can see it coming out that and there. And so what's happening is it goes up and then at some point it breaks off and then gold just really slowly grows and grows and it grows tall. It grows 6 feet,
But only on that one.
No, anything else. Any of the sea fans, I haven't seen any of the crested corals. But as the bamboo is picked because I think it just stands taller and it strains more water, so more plants are likely to fall there than they are in other places. But we're basing this on a few observations. The thing that we've been able to do is do them over time. Started in '98, ended in 2012, now we're going to end in 2015. So keep going back and keep trying to figure it out.
What do you see about the health of these corals being deeper and colder water and not by the surface and shores and bleaching and all of that?
It's a different system. It definitely is a different system, and that's a tough thing because what these corals experience over thousands of years, when you start talking about that, you're getting into sea level change.
Yeah.
You see sea level change by 100 years, and that changes the oceanography. And you saw the environmental change on there. That could be attributed to some of those type of things. And so we don't have a real sense of it. We're just now getting into the environmental monitoring and trying to get to flow because flow, I think, is a very important aspect. Corals grow where the currents are swift. And the idea is that the faster the current blows, the faster the particulate food comes to you. Where if you're in a place where it's slower, it might be harder to grow. So we're trying to get a sense of how corals pick, where they grow.
But you don't see dead colonies or things that
We see dead colonies. In fact, the gold colonies are the ones we see because they take forever to rot.
they don't die.
They don't die. They basically have very long life history in general. But then the other corals, they may die and they may go down really quickly and we wouldn't see it. They're individual colonies, so it's not like a big mass of bleaching occurs and then there's a dead structure. Something falls over and then it's prone to probably, weathering away. It weathers slowly because the temperature down there is like 10 degrees C. And so there's not a lot of biofilm. I'm sorry, you read it.
Is the host coral underneath the gold coral completely dead, or is it still alive?
Once it's completely under the coral, it's dead. But like that one that we showed, it had a little bit right there, sitting on the top. It's underneath the coral, you're dead, but because it's a skeleton. If you can imagine your skeleton, and then one part of your arm was you, and the rest of it was gold. Well, is that me? I don't know. That's the nice thing about a coral is it's a polyp. That's the coral. The skeleton and all that's a colony, right? It's a group of animals. It's not just this is me. No, it's that one little thing.
There's a slow death.
Yeah, it's a slow death. Yeah, so definitely is. Yeah, did you have a question? No.
How big are the pots? How much do they weigh? And why aren't they moving in the current?
Those are great questions. They're really good questions. They are small, tiny flower pots that big. They weigh the weight of a flower pot. So it's.
You didn't put that in?
I didn't put that in the concrete or anything like that. I put a little string on them, a little float on them, and you put them on the bottom, and they will stay there forever unless you hit reverse on the thruster, and then the thruster will knock them over, and that's why sometimes when you saw them, they were undersized, because we bring the sub down, and the part goes, and we set it up right again, we take off, and they don't foul, because you're at that depth, there's no light, so nothing grows unless it's going to be an animal that can basically live in that system down there. So that flower pot looks pretty much the same.
Even current shouldn't be very strong down there.
Well, there can be currents down there, there's no doubt about that, but the nice thing about the flower pots is they just, they're concrete, they sit into the thing, they have traction, and they seem to do really well. They don't seem to have well. So you need to have it, because there are times you go back and you go, this doesn't look right, this doesn't look like the right thing. And I'll go down to my little video deck with the die from the previous one, and I'll sit there and the sub, and there's the flower pot, and then we'll work our way back, and we'll say, yeah, there's the other colonies. Like, yeah, this is it. This is the right place. And so, the flower pots were a good idea, even though they were a very last-minute idea. And so, it's used a lot. Sometimes you put temperature recorders in. Yeah.
Are you placing the flower pots and turning them right side up, right, mechanically? It's not a human being that's out in the water.
No human beings out there. You can't get out of the sub at that depth. There's a waiver. Shopping mall, as the sub pilot likes to say, Terry Kirby said, you couldn't open the hatch to go out and do it. So they have a robot arm, and they basically just set it up right, and yeah, it's pretty straightforward.
Can you just briefly explain like how the subs are deployed?
Yeah, it's interesting. I actually had a really nice photo in there, and it didn't show up, but maybe we can go through and see if we can find it. But if they're deployed from a vessel, a support vessel called the KOK, the Kanikaio Kanaloa. It's a University of Hawaii vessel, and that right there is the robot arm that you just asked about. That's what you collect your samples with. And let's go here. And the sub basically has, or the ship has a hangar that it stores the subs on, and it does a really good job at putting them over. Let's see here. We'll take it over the top. Okay, where are you? And what it does, it has a handling arm that lifts it up and moves it over and puts it back down on the bottom. And there it is. And I don't know why it's, there it is right there. You got it? Yeah, that's what I meant to show you. So yeah, right, not a very good view. And you can see it, it's a really nice ship. They basically, they have two subs. They come in white and yellow. That's the Pisces 4th, Pisces 5. Basically, they have a hangar, they roll it out, and they get in the sub, and they lift it up, and gather you over, and they set you down. And yeah, it's cool. The thing about it is we don't know how much longer we're going to have them. I think currently, if you looked at the Hawaiian Airlines magazine, Hawaiian Airlines, there's a story about Terry Kirby in there, and it actually talks about the lack of funding for those subs. So we may not have them in the future. And personally, it will be very hard for me, but it's actually really cool. So let me see if I can. Speaking of the subs, see
The
if
subs, you can get like 3 or 4 people.
you can get 3 people in there. One of them's got to be the pilot. So the pilot's in the middle, and then like I said, that's an observer on the left, and on the right would be yourself or whoever's the person sitting there. And I'm going to see if I can get this to there. Is it going or not? So, no, it's fine. Hang on a second. There. All right, so this was one way down. We actually had the SEAL come down and look at us. So, it's pretty amazing when you're sitting on the bottom there and you're studying corals, and then this thing comes in and looks in the porthole and basically swims around. I wasn't on this dive. This dive had Amy Bacher-Taylor and some others in there, but the SEAL came down to look at us, and it's actually looking around using the light field, taking a look at what we're looking at. And my guess is that it was taking advantage of the fact that it's an illuminated area, there might be some fish that are captured. So it was applying it smart use of its dive, I think.
How deep was it?
It's 536 meters. This is the deepest dive we've ever seen with the seal. So, it does make you wonder, maybe it was on its way down and it saw some light down there. Now, why would it go look at light? It might go look at light because it's used to seeing something fluoresce. It might say there's something down there and go take a look at it. And it turns out it's a huge sub and 3 scientists looking at corals.
Any theories why they're not, gold corals aren't taking over the other types of crystals?
No idea. It might just be that it could be too low. Yeah, she's right. The fact is they're all really low, right? So that's a possibility. Now, we do find little Midas colonies on low coral, so that could occur. But it could also be that you want to have, might be that the nematocysts in the coral or something like that, something that they'd have to fight with, but we haven't seen it. That doesn't mean it doesn't exist, though. It just means we haven't seen it. A lot of this stuff that I'm saying is stuff that, you have a few observations, and until you go out and take more time and you look at it, you're going to find it. Like, I'm not seeing any gold coral on those filamentous whips, yet they sit up beautiful 6 feet, but they're not a lot of surface area. They're one strand, but they are bamboo, so why wouldn't we see gold growing down one of those? And so, I had to go through the entire database, the whole database. They may actually have one in there already growing on there. So yeah, that's important to remember. It's what you know. That's all you know.
Is there any other gold coral species like in other parts of the world?
Yeah, no, there are. I mean, until recently, gold coral was called Gerardia species. Nobody knew what it was, and so they recently put a name on it. They got a Hawaiian name on ours. It's Hanauma, I think, right?
Yes.
I'm butchering it, I'm sure. Yeah, so they basically got a name on it, which is nice because I still call it gold just because it's easier for us to talk pink, gold, black, But the reality is it's nice to have a name on it because Gerardia sounds a little bit like the waterborne disease. Yeah, way too fond of the coral to use that, so I'm glad they came up with a good name for it. So.
Is it good for making jewelry out of?
Yeah, this is one of the ones that they use for jewelry. And if you look at some of these, well, no, it's pretty dense. If you take a look at that, that's the new piece right there, and that's an old piece that's been sitting on the bottom. You can see the host in the center of that right there.
It's tiny.
Tiny, yeah, they're very tiny. So,
Is it a branch of gold here?
well, it could be. It's hard. Yeah, it's a branch. It's just like a tree with little branches coming off.